In this set of problems, we want to look at the integers from 10 through 99. And in the first question, we are asked how many integers are there from 10 through 99. So we're going to use this formula. The number of integers from A to B is B minus A plus 1. So we'll take 99 minus 10, and then we add 1, and that gives us 90. Let's take a look at the next question. Now we want to know how many odd integers are there from 10 through 99. So we know that there's 90 altogether, and every other integer is odd. So that means that half of those will be odd. So we'll take the 90 divided by 2, and that gives me 45 for this one. Now we want to know how many integers from 10 through 99 have distinct digits. So before we were looking at odd, now we're back to just regular integers, and we want to know how many of them have distinct digits. So we want to eliminate 11, 22, 33, and so on through 99. So how many are we eliminating? We are eliminating 9 different numbers, right, from the list. So we had 90 to start with. Take out 9 of those, and we have 81. Now another way of looking at this is that we've got 2-digit numbers, and the first digit can be anything from 1 through 9. Can't be 0, right, because we're starting at 10. So there's 9 possibilities here. And the next digit could be 0 or 1 or 2, all the way up through 9. But, so that would be 10 possibilities, but because they have to be distinct, we have to take away 1 for whatever we used in the first place. So there were the 10, 0 through 9, minus 1 gets us back down to 9. So it's 9 times 9, which gives us 81. So 2 different ways of looking at that. Either way, you get 81 for the answer. Okay, so we've got 81 there. And now we want to know how many odd integers from 10 through 99 have distinct digits. So I'm going to use that technique again of looking at this as 2 tasks, choosing the first digit and choosing the second digit. So if it has to be an odd integer, then the second digit could only be 1, 3, 5, 7, or 9. So there's 5 possibilities there. And the first digit can be anything from 1 through 9, so that's 9 possibilities. It just can't be 1 if our second digit is 1. It can't be 3 if our second digit is 3, and so on. So it's 1 through 9, but then there's 1 that we have to take away from that. So 1 through 9 is 9, but then taking away 1 brings us down to 8. So we have 8 times 5, which gives us 40. All right, so now, what is the probability that a randomly chosen 2-digit integer has distinct digits? So, randomly chosen 2-digit integer, so that would be the 81 that we got. That's from here. And we're going to divide that by 90 because that's how many 2-digit integers there are. And we got that from here. So 81 over 90, which is 9 over 10, or 90%. You want to give it as a percentage. And then we want to know what is the probability that a randomly chosen 2-digit integer has distinct digits and is odd. So now going to look at this instead. And so we have 40 out of 90, and that's 4/9 as a fraction, or about 44.4% as a decimal. And that's how you do those problems.